Some famous examples for a vector space. Plane is a vector space. So remember that plane is basically the Cartesian product between R and R, or it can be represented as R to the second. This is the set of all x and y's such that x and y are both real numbers. Usual, you can define U to be x1, y1, and V to be x2, y2. The usual vector addition and also scalar multiplication gives us a vector space. We can generalize the idea to the plane in the space and also space and then Rn. So in general, you can say that, hey, R2n, which is nothing but the Cartesian product between R and Rn times, which is basically is the set of x1 and then x2, x3, xn, such that xi is in R, I ranges between 1 to n, is a vector space. For example, you can define vector v to be v1, v2, v3, vn, and vector u to be u1, u2, u3, and un. The same as before. Vector addition and scalar multiplication makes Rn to become a vector space. Another example for you. We can take all matrices of size 2 by 3 and use addition and scalar multiplication and create a vector space. So the set of all 2 by 3 matrices is a vector space with matrix addition and scalar multiplication that you saw before. You can check all of these using the axioms that we introduced in the beginning of the course.